Yeah, so this is all we have for a lesson today. This is it, and you're done with this unit. So nice job. You don't have to write this down. So these are really the four things that we've talked about. And as you can see, three of them are very heavily related. So number one, we've been spending a lot of time practicing problems in the net change theorem, right? And all those applications. That's like the checkpoint that we just started out with. But finding antiderivatives, so those general integrals, you can see those indefinite integrals. We did integrals by substitution, and today we're going to look at substitution of bounds. So it's really just kind of two big ideas. Number one, antiderivatives, and number two, net change theorem. That's really the big idea. And the substitution rule for definite integrals is kind of like this. This is not how the textbook would write it, but this is how I'm going to write it. So if we have the antiderivative, or the integral from a to b of f of x dx, and we know you just, you take, big F of B minus big F of A, right? But it turns out that if you substitute something in, so instead of X, suppose we change the variable to U, okay? I'm going to write X is equal to B and X equals A. Those are always X values, right? We bound them from say left to right on your calculator, we do that? These are always X values. Well, we talked about changing this integral from x. We said, well, what happens if you change it so it's u instead? So what if we go u? Well, what happens to the bounds? Well, you just find u of a and u of b. And we'll see what that looks like here in just a second. You don't have to use this all the time, but I may ask you on test, please show this definite integral by using substitution of bounds. So here's what we want to determine is the integral from 0 to 2 of x times x squared plus 3 raised to the 4th power dx. And I understand if I want to take an antiderivative of that, I'm going to want to determine u. What is u? Yeah, x squared plus 3. And what is du? 2x dx. Anyone? 1/2 du is equal to x dx. Remember we tried that like a couple days ago. It was confusing at first, and I'm like, that's super easy, right? Okay, great. So I've got my substitution, 1/2 integral du. And what do I get to get rid of when I do that? Yeah, the x and the dx are gone. So what remains? Yeah, u to the 4th, right? And now what I can do is I can change my bounds. So because your variable has changed, it's not x values anymore. Now it's u, isn't it? So I can't use 0 and 2. So what do I use? I use 0 plus 3, which is 3. And I use 2 squared plus 3, which is 7. That's it. That's all I'm teaching you today. So I'll show you. Let me finish the problem, and hopefully then the why you'll see, okay? So what's the antiderivative of u to the 4th? U to the 5th over 5. So when we multiply by 1/2, everybody agrees it's going to be u to the 5th over 10. So you don't have to plug in x anymore now. You just go 7 to 3. You can just deal with u from now on. See what I'm saying? And so in this case, you would get 7 to the 5th over 10 minus 3 to the 5th over 10. And I don't know what those are, but 7 to the 5th minus 3 to the 5th all over 10. I don't really want to figure it all out, but don't need, so plus C is if we have this. But if we have this, then we actually need a numerical result. We need a number as a result. If we have this, then we have a general antiderivative that's a plus C. Difference between the indefinite and the definite integral. Yeah, exactly. So there's two ways of solving this. If you wanted to, you could plug x squared plus 3 back into here, but then your bounds would be 0 to 2. So if your variable is u, then use 3 and 7. If your variable is x, then use 0 and 2. See it? That's it. Yeah, that's it. That's all there is. Let's do example 6 and we'll call her good. Anybody, what should u be in this scenario? Sine of x, and so du is? Yeah, cosine of x dx. What? That's pretty handy, isn't it? Yeah, I mean, it's like, if you counter that problem in the AP exam, you're like, this is like Christmas, you know. So I've got a straight up substitution here of just integral du. And what's left over? U to the third. Now, I'm going to continue to work with the variable of u. So I'm not going to bound it from 0 to pi over 2. How I figure out my bounds is I simply take these and plug them in for u. What is the sign of 0? 0. And everybody here knows the sign of pi over 2. 1. What's that? Antiderivative of u to the third. And we're going to evaluate that at 1 and 0. So you don't have to use a 0 on the pi over 2. You just use 1 and 0. We'll set real quick. Okay, so that's the video lesson for the day. Anybody who's watching, that's it. We got a test on Tuesday. I'll get your study guide ASAP. And now we're going to open up for other questions that people have about other content. So don't feel bad if you have questions on your previous worksheet, folks. Definitely some